Hey, you might remember this. This is the Lumin Plus. It just changed colors, which is exactly what we're about to talk about. This was from one of my first videos ever on Bluetooth sniffing, reverse engineering, etc. I pulled it out of mothballs because I was introduced to something called Cheerlights.com, which is a way to communicate to all the cheerlights on the planet what colors they should be. So I thought it'd be kind of fun. It's not a complicated project, but we're going to discuss, obviously, Bluetooth Low Energy. We're going to look at MQTT, and we're also going to look at setting up Wi-Fi on the ESP32. So with that, stay tuned. Let's build a Cheerlight. All right, hopefully you can see this. I know there's some hot spots on it. We're going to use the Lumin Plus, which you can pick up at 5 and below, $5. We're going to use an ESP32. And the way this is going to work is Cheerlights monitors Twitter. Whenever somebody puts hashtag Cheerlights and a color, Cheerlights picks it up and puts it in their MQTT server. MQTT is a publish and subscribe model. And what we will end up doing is with our ESP32, we're going to connect to our local home network. We're going to subscribe to the MQTT Cheerlights message. And when we get a new color, which is posted to Twitter, we will update our color on the Lumin Plus. So it's kind of a silly use case. I mean, it's fun. You can use it as a nightlight or something. But it really introduces you to a number of technologies, and that's really what we're going to be focusing on. I will show you, how you do the Wi-Fi, how you talk to MQTT. We'll send ourselves a message. We've already covered the Bluetooth, but that'll obviously be in here as well. We'll talk to the Lumin Plus. Also, just for fun at the end, I'll show you how to convert your Lumin Plus from battery operated to wall wart, so that you can just leave it hooked up all the time if you want it. So all right, with that, let's go take a look at the code. All right, so we're going to take a look at the code, but first let's just see how this thing works. I've got one camera on my Cheerlight, but let's go to the website. If you decide not to make a Cheerlight, if you go to the website, you'll see all about the API, and you'll also see this live button. If you click live, it'll actually show you what the Cheerlight is currently set up for. So this little light right here in this animation is what the Cheerlight is currently set for. It's the last command it received. I think I sent that command. So if I go over here, here's my last command, and I say Cheerlights red, and I tweet it. There we go. Let's go back over. Now mine should change here shortly. It just did. It's much faster than the animation, but the animation should change up. There it goes, red. So you can kind of also see what's going on with Cheerlights, if you will, just by going to this page. You don't have to build one, but I recommend you build one because it's kind of cool and you get to play around with different stuff. As I mentioned on the whiteboard, we're going to use MQTT. MQTT is a subscribe and publish methodology. I'm under the impression it was actually used for some satellite communications, but I heard it was actually used for some pipeline stuff. So I don't know which is true. It doesn't really matter. We're going to use it. Cheerlights is actually using it. So let's go take a look at the code. So you're going to need a couple things. There's some libraries recommended here. We're going to use an auto connect library, which means that you don't have to hard code in your home network SID or password. You can if you want, but I'll show you how this works in just a few moments. It's kind of nice. If your ESP32 is not on the Wi-Fi, it creates a soft access point you access through your phone or computer or iPad, and you provide it with the credentials it needs, and then it can connect to the network, and boom, everything starts working. So this code will be available on my Bitbucket YouTube project. The link for it should be under the video. So we've got the address for the MQTT server at Cheerlights. The Lumin Plus seems to have gone through some revisions, and the latest version has a different server name. It's called an LD-0003. In the past, it was called this, and that's what it was referenced in my first set of videos. So feel free to play with yours. You can always look at it with like the NRF Nordic stuff to figure it out. This is the command to this is the actual service, and then this is the command to change the colors, and then this is what we set to do the colors. There's also on-off commands. I didn't actually make those calls in here, but somebody was asking about them, so I just put them in here for now. So there's a number of things that have to happen. We actually do create a web server on the ESP. That way the Auto Connect portal can present you with a page on your phone, and so you can answer. Obviously, we need a Wi-Fi client, and we're going to use an MQTT client, all available through these libraries that I mentioned. Root page is simply a redirect, and I'll show you what that does, but it basically redirects you while you're in the soft access point to some information. Actually, what it allows you to do is once the device is up and running, the ESP32 is connected, it leaves the web server running, and you can actually see some information about what the ESP32 is doing. Here, let me toggle over and show you that real quick. I think I know the IP address. I think it's 192.168.1.29, I think. Yep. Okay. So my ESP32 is already on my network, and it shows me this information. It's showing me, it's already established the connection, the mode, the IP address, everything. You can configure a new IP if you want, or a new access point if you wanted. It shows me the networks that are available. I can disconnect, I can reset it, do all those kind of things. So it's kind of a neat interface, and it makes it easy. If you want to build a Cheerlight for a friend or something, this way you're not hard coding in the SID and the router password. This allows them to do it with some fairly basic instructions. So let's go back. So that basically just redirects you to this page called _AC, which is where the real information is. This is called to set up MQTT with a callback. This is called to reconnect the MQTT, and this is the client ID that I'm giving to Cheerlights. You can see that it's got a random ID associated with it. Just a random number at the end. This is the callback. So when a new color comes into the MQTT, since I'm a subscriber, I get notified, and it sends a string of hexadecimal values, RGB colors, with a pound symbol in the front. So what you see here is some code that figures out, okay, well, is this the right message that I'm looking for? And then breaks those bytes down into 1 byte values and converts them so that I can use them in the RGB color data that I'm going to send via Bluetooth to the Lumin Plus. So this automatically gets called. This sets up the Wi-Fi. This is the access point name. You could change it if you wanted. I'll show you on my phone in a few minutes what it looks like when we connect for the first time. This is the BLE code, very similar to what was in the sniffing reverse engineering examples. Here I am basically checking out and saying, is there a device on my network with this name, and can I connect to it? And there is some serial output if you hook a serial monitor to it, so you could change it, debug it, etc. This is the call to start the scanner for the devices in the Bluetooth. So I've tried to name things. So if it says BLE, obviously it's Bluetooth related. If it says Wi-Fi, it's Wi-Fi, and MQTT, it's MQTT, obviously. This is how we connect to the server. So we first scan for the BLE server, then we connect to the server. So if we really get down to the heart, all of these Android firmware devices typically have a setup and a loop, right? You guys know that. So in the setup, after I've shown you all that's above, and it seems kind of confusing, it really becomes simple once you see the setup and the loop. So I turn on the monitor so we can output some debug information. I call setup Wi-Fi. That starts the Wi-Fi. It returns after the Wi-Fi is connected. Then I call setup MQTT, and I pass it some information about the Wi-Fi network it's on. Then I set up the Bluetooth. So that's all there is to it. Very nicely packaged, small pieces that you can go and play with. So by the time we get to loop, I should be connected to all of these things. So what I do then is I just play it kind of safe. I say, am I on the network? Do I have Wi-Fi connection? Yes, I do. If I don't, I need to set up the Wi-Fi again. It's been disconnected. I say, am I on MQTT like I'm supposed to be? If not, I need to make that connection. And then the question becomes, am I connected to the Bluetooth device? I need to do a BLE connect. That means I'm not connected, so I need to connect. Otherwise, I'm connected. If I'm connected, all we have to do is say, okay, I'm connected. Make sure I can actually talk to the device. And if we can write a response, this is really the key. Do BLE RGB. Do I need to send the RGB data to the BLE device? You'll notice after I do it, I don't have to do it again. So where does the RGB come from? Well, that comes from our callback MQTT right here. And what does it do? It checks the package and then it says, hey, we need to set the color. So there's our true. So that will only be set to true when the color changes. So go back to the loop. Yep, we need to do this. This is only for debugging so you can see what the values are. And then I send the data to the Lumin Plus and boom, now you don't have to change it anymore. By the way, if we're not connected, you might need to start a scan to find the Bluetooth device. So there's all these, catches. If you're not connected anymore, try to reconnect. If you're not on the Wi-Fi, try to reconnect. If you're not on the MQTT, try to reconnect. And that's what's going on. That's all there is to this. Someone had asked about turning the device on and off remotely. All you have to do is once you're in here is write that value on and off. The on and off command. All you have to do is write those strings, size of those strings, to the Bluetooth device and it will turn it off and on. It's actually a soft on and off. Physically, it has to be on first. Then it can do this soft, I guess maybe low power mode kind of thing, and then back on again. That's all that you have to do. If your device is a Lumin Plus and, talks the commands that we reverse engineered in that old video I shot. So that's all there is to this. So it's hopefully all packaged in a way that you can learn something from it. It's not terribly complicated. You can add things to it if you want. And it's kind of fun. Go online, change the color. So with that, let's go ahead and take a look at what happens when you hook up a brand new device to your network and how you go through the process of connecting it to your home network. Okay, I'm going to go ahead and plug in the Lumin Plus that I wired for the RGB, and I've got my iPad here, and now I'm going to go into settings and we should have an access point available to us. There it is right there, the ESP32 Cheerlight. So this is the soft access point I explained earlier. So if we choose it, we should now get a captive portal, pops up, and basically it shows us some information. Established connection not available. Okay, so we need to configure a new access point. So I click that. It's a little slow because it's scanning. And I'm going to choose my home network. And I'm going to enter the password. And then I'm going to press apply. And now we've established a connection. And the device actually changed colors, which most likely means that there's been a new color sent from somebody on Twitter. So that's all there is to it. You can do disconnects, reconnects. So when you send this to a friend, if you make one for somebody, they can easily hook it up in their house. That's the point of all this. That's the point of using the AutoConnect. All right, well, I hope you like this project. I know it was really simple, but it covered a lot of different types of network issues, networking scenarios, and protocols. So hopefully you got something out of it. All right, take care. Hey, remember, subscribe if you haven't, and learn something new every day. Bye. Alright, so if you have a Lumin Plus and you don't want to have to keep putting batteries in it, and you want to power your ESP32, let me show you what I did. First thing you do is you want to crack the glue inside. You'll hear it kind of crack. You can use a spudger kind of tool and kind of get it in there, and you're going to pop this thing off. And if you notice, you've got, this is where the push button is on the outside. I've also had to cut a hole. I'll show you why. So here it is. If you take the battery casing off, you will see that I have cut out where the batteries go. I've removed the battery connections. I have, using a Dremel tool, I have cut a square out, and then I attached a DC jack to the back of it using a drill, brought it to the inside. Fortunately, I'm using a 5-volt wall wart, and you will see when you open this up that the circuitry that controls the color of the light, it's marked really well, so all you have to really do is do a little bit of wiring. I've taken the ESP32, I've programmed it, I've slid it inside. You could probably hot glue it if you wanted to. I ran the wires to both this board and the other board. They're in parallel here, and that's all there is to it. So if I close it up, you know, where you're making the cuts is important. Where you're making the cuts so that everything fits together is important. And if I take a wall wart and plug it in, we should be able to see it work. Yep, plug it in, press the on button, and there we go. It's on, and the ESP is running. That's all there is to it. Don't want to spend too much time on it. You can figure it out, I'm sure.